Thank you so much. I'm Jay, and I'm an artist. I am also a PhD student at RMIT. I create art using machine learning, augmented reality, and 3D modeling to explore gender, and non-binary gender in particular, which is very close to my heart. And I'm going to talk about the two hottest technologies of the moment and how they can and are being used together. I'll discuss my journey as an artist and the toolkits available for development and the ways people are using these technologies now, as well as my hopes for in the future. And art, because I really love art. I often get asked, how did you get here? And isn't machine learning really hard? And I get that. I'm an artist, I'm not a traditional developer, but I do have a small background in coding back in the long, long ago. And I know enough. What is that they say? A little knowledge is a dangerous thing? Yeah, that's me. I didn't know machine learning was hard when I started. I think that's the thing you all need to know. I saw something cool and found a repo with instructions. I had to learn everything. But I was excited about the project and the possibilities, and I dove into the deep end head first. And it wasn't until I was in over my head that I realized how difficult it all was. And by then, the only way out was through. And then another project came along, and another way of doing things, and another. And I just got swept up in it all. Because when you're passionate about something, when you're excited to get going, then there aren't that many barriers to entry. As long as you're stubborn, and you remain enthralled by the thing you're pursuing, and the resources are there, you can work your way through anything. That is why machine learning and mixed reality and IoT are so exciting. Because not only can you make amazing things, but the resources are there to help you with almost every problem you come across. And I should know, because I've run into a lot. But I'm getting ahead of myself. An artist and a developer, how does that even work? Don't they use different parts of the brain or different and totally unrelated abilities? Absolutely not. You would be amazed at the mathematics that are present in painting, in planning an artwork, in arranging the composition, the physics and chemistry in mixing the colors, producing a painting or a sculpture. Creative endeavors are seen as easy, because the hard science beneath is cleverly hidden. But painting and art making are just another facet of creation, just like producing an app or a web page or a robot, and all creating uses a wealth of skills. Programming is a language, like art, and programming is an art form. But when people ask me, isn't machine learning really hard? My response is, so is everything that's worth doing. Because it is. Everything is hard at first. Painting is hard. Programming is hard. Everything involves knowledge of your framework or your substrate, your materials or language, and the basic principles underneath that help govern your practice and your creation. And you don't need to be Picasso to start either. Anyone can pick up a paintbrush or a camera or a language, but you have to dedicate yourself to it. You have to decide to make something amazing. That decision is what matters. Not the skill you bring into it at the start, but the decision to start and the skill you evolve as you progress. That and what you have to say with what you make. What do you want to say? And how do you want to say it? Anything worth doing should involve asking yourself those questions and then working through the answers. It's as simple and as difficult as that. Whether you're making art or making code or both, those questions should be your first stop. When I started in my master's degree, I was a painter. I made 3D models to act as life models for my paintings. And then I had a conversation with the head of department during a review that went along the lines of, look, your paintings are good, but, And I'm like, oh no. But he went on to say, but these renders, this is where it's at. And it caused me to take a good hard look at where I wanted to go. Because over the years, I had started enjoying the process of painting less and less, and the 3D modeling more and more. And I was enjoying learning about different things I could do with it. I wasn't saying anything truly new or unique with my painting. So, in a way, this was my opportunity to say goodbye to painting for a while and go after the area I was most interested in, my art and my computer and the things we could make together. So deep in the throes of my master's research, I saw a simple augmented reality app commissioned by a fellow artist, Jim Thalassoutis, to bring one of his paintings to life, and it inspired me. I found a simple app, Orasma, that would allow me to create online, and I put together a short animation. I shyly showed one of my professors as something I'd just been playing around with in my spare time, and he literally took a step back in shock. And I was like, oh my God, I was hooked on that moment, on that reaction. And I was captivated with the idea of revealing a truth behind the work, to be able to show more than a printed piece would allow. I'm a gamer, and I love the idea of hiding Easter eggs in my work. But I still had to find something to say with all this technology, because it's all very well and good having awesome technology, but as my supervisor said to me, where is the art? And I took that to heart, and I ask myself every time, because the art is the important part, the message, the meaning, the reason for its existence. While I was muddling through the dilemma of what to say with my AR work, I saw an Imgur post on style transfer, and I started to delve into the possibilities. I was already intrigued by Deep Dream, but I couldn't see any use for it in my work. But this just clicked for me. My work uses a lot of archaeological influences, and I thought it would be interesting to see the computer reinterpret my work in the style of its original inspiration. But the easy-to-use website ostagram.ru was down because the post went viral. So I furiously scanned the comments, looking for another option, something, anything that would allow me to harness this amazing technology. I was already so obsessed. And there it was, a link to the repo. I barely had any idea what I was doing, but I remembered how to use command line functions. It couldn't be that hard, right? That first repo used Torch as the framework and Lua as the language. And I remember going from repo to repo, site to site, learning how to download all of the dependencies because it didn't have a requirements.txt. And I learned how to use pip and homebrew. And it took me a few days, but I got it working. It was hideous, but it was mine. Well, mine and my computer's. I didn't know where it was going when I started. I still didn't know what the art would be. I was still hooked on the technology at this point, but I could see something there, some potential for augmented reality and machine learning together. And it started to resolve. I started working with the base code, but my favorite part was the way the works would slowly transform across the iterations. And finally, work started to take shape. But I hit a snag. It turns out Orasma was very expensive if I wanted my own branding and interface. So I started to research more options and realized that the cheapest way would be to make an app myself, using a library like Vuforia or Wikitude. After all, how hard is it to get an app approved on the App Store? It couldn't be that hard, right? I asked myself that question a lot. But thanks to the power of Google and a lot of hard work, I made my first augmented reality app and 14 machine learning animations that shifted back and forth, that were presented with 7 realistic renders and 7 laser-cut abstractions based on the machine learning outputs. And the art? Where is the art in these works? I titled the app Recursion. Recursion is where a function being defined is applied in its own definition. In linguistics, it's all about repetition. Each artwork is repeated in this series and resolves to each other. There's a pattern in each one. In gender, the act of defining your own gender also helps clarify it for you and contribute to the known definitions of gender. We define our gender for ourselves and then apply that definition, and that helps others with their own gender journey. These works are about transness and about non-binary and non-passing transness in particular. They're about the internal journey of being a trans person and how we are so much more than our bodies or our outward presentation. In this case, the art is more than what is on the wall, but a deeply personal internal monologue for each person. This was my first exploration into machine learning, and I was hooked. My research for my PhD is on computer perceptions of gender and the way that machines learn and create. And there is no better medium to explore that than through the lens of augmented reality and artificial intelligence. My most recent works explore gender with a mixed data set of marble statuary. The results blend gender together in a way that I'm fascinated to continue exploring. As I was going for an abstract field, the data set was small. It was only a bit over 4,000 images of Greek and Roman statuary. I selected my favorites and made drawings of what I saw in the works, the sculpture emerging from within the abstract forms. And from those drawings, I made 3D models. And from those models, I made augmented reality interactions. While close, you see something abstracted, but as you move back, it resolves into something more tangible and real. Like with pointillism and cubism, you can appreciate the details close, but it's only until you step back and take in the entire work that the forms start to resolve into something more than the sum of their parts. It also reflects the training process of the works, the slow coming into being of certain forms, and how people often lose sight of the big picture while hyper-focusing on minute details of trans people's bodies. I also trained an image classifier that specialized in turning captions into short stories so that it could write a narrative about the works created by the GAN and the works created by me in response. From here, I united them both in unity, the spoken word, music based on the generated words, and the interactions. Captions and options to turn on and off the sound were added and submitted to the different app stores. By mixing different media, displays on the wall, music, speech, and 3D modeling, I'm leveraging mixed reality technologies to keep it all in place and create an installation experience. While the technology is cool here, the meaning is clear. It examines the social construct of gender and assumptions based on first glances. The soundtrack elements for this series was inspired by the work of Troy Innocent, who uses augmented reality and creates work around the nature of code and concepts of pattern recognition and how they affect the world at large. His highly geometric works, both in gallery and location-based works in Melbourne's iconic laneways, are centred around code as a visual language, and the augmented reality component fires off sound elements, overlaying digital map keys and weather visualizations, showing machines' responses to pattern recognition, as well as our own. While there is no machine learning directly in these works, they explore the concept of the daily machine learning that surrounds us. Art in augmented reality already has a wonderful history and an exciting future. MoMA are activists with their own app taking over space in the Museum of Modern Art, democratizing art and creating a message about elitism in the art world. Their app and installation is open source and situated in the Jackson Pollock Room, where it has unofficially taken up residence as part of the permanent exhibition. While this seems parasitical in nature, leeching off the reputation and marketing of the gallery to leverage their own exhibition, it's more of a symbiotic relationship, as the app and the press around it has driven visitors to MoMA who might not have otherwise attended. Many people love to unlock secrets and find hidden things to reveal. It's a way to gain new audiences that engage with the art in new and interesting ways. While detractors see a desecration of institutions, defenders see democratization and an exploration of art beyond the confines of what has been established in the annals of art history. From sculpture installations to graffiti to location-aware art, we are seeing artists explore the possibilities of adding layers onto our world. There are collaborative augmented reality art projects and ephemeral works, permanent works, and thanks to public art collectives and mavericks like MoMAR, augmented reality can even be seen as a form of open source for art. This puts art back in the hands of artists rather than in the hands of elite institutions and galleries. It allows us to subvert the mainstream and create our own realities to hack the art world. And with emerging browser-based technologies, we can enable it for anyone with a browser in an instant, rather than relying on an app download. Extended reality is the term for layering a new, interactive digital reality on top of our existing mundane one. It encompasses interactive mixed reality, augmented reality via traditional means and wearables, and virtual reality. A world layered onto our own a screen's width away. A world of digital creations and digital intelligence. We grant access to other worlds through augmented reality, so why not explore those spaces where machines learn? There are a number of platforms for developing augmented reality depending on your budget and objectives. You can pay to get a white label app from Orasma and do everything via their web interface, or if you're like me and you have no money, and you're happy to experiment with the possibilities, you may find Vuforia, Wikitude, Eighth Wall, or AR.js your best option. The first three all have packages that work in Unity. They're free to test out. Wikitude is free for your first app, and Eighth Wall at this stage is free to use and deploy. They're all excellent development options with pretty much everything you need to get started building your first AR app. In this case, you can build it in Unity, Xcode, or Android Studio, add your interactions, deploy it to the app stores to allow people to download it, and this is so cool. It's really awesome to see your name in the App Store. But it turns out that not everyone wants to download an app for a one-time event, even if it is cool. And Unity is wonderful for cross-platform development, but it's kind of slow. The Unity to App Store pipeline is a lot of work. Your other option is to sideload it to devices and have them available at the venue for people to explore, which then becomes a security concern. So enter AR.js, which is the first of the live web AR-based systems. All your user needs to do is point their phone browser at a web page and then look at the markers or use the live demo options. And it's much simpler pipeline. In fact, if you take out your phones and go to minxdragon.github.io and put them in landscape and point them here, you should see a quick and dirty live web AR demo. And there's no security logging or anything. It'll ask to use your camera, but then as soon as you close the window, your session's finished. And what you should be seeing is some 3D text and a little style transferred art center animating away. Is it working? The terrifying part of any talk. Does the demo work? It does work best in landscape. It has a funny stretching issue in portrait that I haven't solved yet. But I mean, it's a quick and dirty demo, and it's still somewhat rudimentary because the marker recognition is mainly for classic AR-style markers. But the resolution and speed are surprisingly good, and the future is looking ripe for web-based AR development. This is just a few lines of code, a surprisingly small amount. Is it working? Do you have it? Yeah. Woo! Eighth Wall have just released their own web-based AR system, which has a very powerful simultaneous location and mapping technology, allowing things to appear on the ground like they're really in the world. They've also just introduced image targets. Google and Apple are both working on web AR that leverages ARKit and Core. These all use JavaScript and A-Frame Web VR, allowing us to use WebGL, which is live 3D rendering for the web. WebGL can be created in online programs such as Sketchfab, or in more sophisticated programs like Blender. And suddenly you can leverage all your 3D content online. Now, why does web-based augmented reality excite me so much? Because of emerging machine learning technologies for the web. ML5JS is a group of JavaScript libraries specifically for machine learning and are making machine learning technology accessible to many developers. JavaScript libraries like these and AR.js use just a few lines of code to allow access to a new world of development. It's still early days, but this technology will be at the forefront of browser-based machine learning, and many of them already work with phones. Emoji Scavenger Hunt uses TensorFlow Lite, a lightweight web-based framework for mobile use. And it's a great example of an online machine learning game that pulls together webcam footage with a classifier to find real-world emoji using TensorFlow.js. There's a demo on their website and the code to implement it yourself. Many forms of machine learning already rely on camera image classification, PoseNet and YOLO, which in the machine learning world stands for you only look once, rather than the more common you only live once. All of them use live webcam data and superimpose their results over the top. This is, in a way, a form of augmented reality, and in the future can be used to supplement live augmented reality apps. Apps like Snapchat and any app that has a similar facial detection and overlay system also uses machine learning and augments reality to display the results. Snapchat filters and the like have become so eponymous with everyday selfies, it's really easy to forget that they use machine learning and augmented reality seamlessly together. It seems strange to think of Snapchat as a leader in these extremely cool technologies, but in a way it's very fitting. It's augmenting our own very personal realities, our faces. Crafting a new appearance and sending it out into the world as a human CG hybrid. Constructed using AI facial detection, a webcam, and augmented reality additions and components. It's post-human in the best sense. Snapchat in particular is quite good at detection, and while you can use adversarial methods to avoid the facial recognition, it's a surprising amount of work to foil. I was surprised it even accepted that Francis Bacon abstract self-portrait. In fact, I'm so obsessed with Snapchat, it's become an area of exploration for me, using a DC GAN to generate images based on Snapchat selfies. I love the way it entwines the hybrid human-computer mashups and brings them together. Computers only understand what they've been taught, and so its interpretations are fresh and interesting. Working with machine learning is never boring. My favorite part is that at different points it focuses on different qualities. It may just choose to render faces for a while as it detects the commonality in all of the images. Then it might focus on the little noses or the glasses additions, creating swirling wires around the eyes. Sometimes it may even focus on people sharing their Snapchat scan codes because I didn't clean my dataset properly. DCGAN stands for Deep Convolutional Generative Adversarial Network. A GAN is actually two neural networks, a generator and a discriminator. They both work off the same dataset. The generator creates, while the discriminator critiques and rejects the creations that don't fit the dataset. Through seeing which works pass and which fail, the generator learns to make works that fulfill the criteria. There are a range of different GANs for different frameworks and outcomes. Pix-to-Pix, which is an image and video translation GAN, is probably the most widely used by the AI art community. There is even a JavaScript Pix-to-Pix for live browser work, but it's a little slow for phones at the moment. I usually use a DC GAN in TensorFlow because of its stability and ease of use. It'll take anything I throw at it, and I throw a lot at it. Apps such as Prisma and Oilist already use feed-forward style transfer in their apps and are well on the way to style transferring our realities. If we return to Van Gogh here with his little Snapchat ears, we have Prisma on the left and Oilist on the right, and Van Gogh's work as the style. Oilist even allows you to change it as it is painting, being the closest we have right now to creating a painted digital reality on the fly. Facebook is working with Prisma to create live style transferred videos, and I wouldn't be surprised if Snapchat are also working on it. Machine learning ranges from everyday uses such as shop recommendations and maps to generating art and music and medical diagnostics. It's a huge area of exploration and the hottest one too. The other hot technology is augmented reality. And it won't be long before we continue to see those coming together more and more, whether in simple methods or complex ones such as creating art. And creating art can be done in so many ways, whether using Deep Dream, style transfer, digital coloring, pix-to-pix, or wholesale generation. We can generate music and videos and even comic pages from videos. The options are limitless for those unafraid to attempt it. And one thing leads to another, and then another, and then another, and before you know it, you're on a stage talking about the possibilities of machine learning in art. Machine learning options are becoming more accessible to everyone with the right tools and interests. Runway.ml is a beta machine learning GUI with hooks for Unity, VS Code, Blender, Photoshop, and more. This allows creatives to get directly involved with making art without all the command line work and framework installation and inevitable CUDA issues. It creates a seamless GUI for the most commonly used machine learning models and may be one of the most exciting things to happen to machine learning in art since the GAN. Because it works natively with Unity, it will be able to work with mobile devices and virtual reality to create mixed reality experiences. Unity and Unreal Engine are prime engines for VR development, putting Runway.ml at the forefront of adding machine learning capabilities to virtual reality and augmented reality applications. But why bring machine learning technologies and augmented reality together? I mean, apart from the fact that they're both very cool, what purpose does it actually serve? Now, I've talked about the two uniting in Snapchat, and I've talked about Instagram filters and things like that, but does it have any real-world applications beyond the frivolous? Do the two together provide meaningful ways to interact with the world? Maybe I can just, yeah. Some of the simplest and best use of AR and AI together are in the form of translation algorithms and language education. Using your device's camera to read a sign and translate it for you in real time, having those results superimposed over the sign. It's clean, practical, and simple. Google Translate is the most famous of these, but there are a range of live augmented reality translation apps available. Apps such as Memrise teach language by using image detection, so that as you point your phone at your cat in the app, it'll tell you it's a gato, or a neko, or a shat. There are augmented reality travel guides and maps that will hover information about the location in your device and tell you how to get around, or allow you to explore a location or a museum just by moving around your home. Imagine how helpful that is for people who cannot travel for affordability reasons or accessibility. ViewRanger is an app that recognizes geological features in skyline and defines them for hikers to show the best trails. It's also being used by search and rescue teams to find lost hikers, making it an invaluable resource. Wikitude World Browser is a practically ancient technology from 2008 that leverages Wikipedia to identify things near you and give you information about it. It uses your location data and image recognition to provide content on worlds of items and locations. If you're like me and you have a bad habit of taking photos and forgetting why you took them, or taking a picture to look up later and then forgetting why you took it, Google Lens is particularly useful. It uses image recognition to return information on photos you have in Google Photos. And while it isn't technically augmented reality yet, it is being worked on to give you live feedback in augmented reality. It can also be used to save data from business cards to your contacts, add a date to your calendar, read reviews about books, and more. Imagine how powerful it'll be to have, in augmented reality, to have the power of Google behind your camera working in real time. Everyone is probably familiar with my next example. It was a worldwide app sensation after its release in 2016 and has remained in the top 10 of app earnings since then. It may seem ridiculous to consider gaming in the sphere of uniting machine learning and augmented reality, but that's exactly what Pokemon Go does. Well, it uses mapping and location technology, which is admittedly not the smartest of AIs, but under the hood, it also uses machine learning to detect cheating activity, such as spoofing, by faking your location and tricking the game into thinking you're exploring from the comfort of your living room. Botting, where you use automated spoofing, and multiple people using the one account in different areas. It analyzes a user's usage and flags suspicious activity for later. Niantic, the company behind Pokemon Go, have also acquired Matrix Mill, a startup working on using machine learning to go behind augmented reality, or in front of it, as the case may be. They're working on using computer vision to detect obstacles and occlude your AR elements so that they appear more naturally in the wild, where if a tree is in front of a Pokemon, you'll see it peeking out from behind, or if someone walks in front of it, you'll momentarily lose sight. Niantic have also just released Harry Potter Wizards Unite as well, which builds on the base of Pokemon Go and Ingress before it, and will expand on the technologies already developed. It appears to be more of an RPG at this point than Pokemon Go, and possibly promises a bit more depth to the gameplay. Retail AR from Dent Reality has been working on a grocery shopping app that will navigate you to the aisle you need and suggest meal options for different ingredients. It uses machine learning to locate you within the store and help you find what you need, and suggestion algorithms to help you decide what to make for dinner. Sorry, waiting for the animation to finish. Yay! IKEA already uses AR for furnishing your room. I doubt it'll be long before they leverage recommendation technologies to recognize your style and the pieces you already own and suggest options based on those and display them to you in real time. There's already something like that for art called Artific, where you answer questions about your taste and then preview art on your walls that suits the color palette of your room. Research into accessibility in combining augmented reality and artificial intelligence is also underway, with a recent experiment using augmented reality headsets to help teach children with autism how to identify emotions by turning it into a game. The children and their parents both reported an increase in their understanding and responsiveness, with one child saying that they're a mind reader. Huawei has created an app for deaf children that uses the phone camera to analyze the words in children's books and reads the story to them using sign language. Many deaf children struggle to learn to read, and applications such as this could help bridge that gap. There are wearables enabling subtitles to be augmented onto movies, and one in development for live captioning of speech in conversation. It will be wonderful to see the world made more accessible with augmented reality and wearables and all of this cool technology. Effort is being made to restore archaeological artifacts digitally and display information about them in situ for tourists in augmented reality. La Lonia is at the forefront of this research, creating an augmented reality presentation for visitors that allows them to explore the unique architectural qualities of the Heritage Protection Building and its construction. Historical sites require low lighting levels, but augmented reality provides greater accessibility and access to the details of the architecture without compromising it. AR is ideal for archaeological sites, preserving them as they are, harnessing the technology of the future to allow us to learn from the past, while maintaining the integrity of the artifacts and the site. But in the future, we will also harness neural networks to restore and translate text for you in your language on your phone. Neural networks will access historical data to restore the original colors of statues and frescoes, an experience preserved for future generations. And then, because we are the way we are, there'll probably be a photo opportunity to insert yourself into a fresco or a mosaic and be seamlessly style-matched. We'll have personal tour guides in new cities tailored to our experiences and past interests, our restaurants that are recommended to us based on their handling of our individual dietary requirements. We'll see medical diagnostics with a human doctor supplemented by an AR headset and leveraging a diagnostic AI to diagnose faster and more accurately than without augmentations. We're already seeing development with machine learning making diagnoses with less data than human doctors and enabling treatment faster with a greater success rate. When you add wearables to the mix, you increase the accuracy of a surgeon's work, to an X-ray technician spotting crucial anomalies, to a GP identifying a mole. We'll see engineering diagnostics helping to solve problems in the field with a handy heads-up display to help locate and fix the problem with a step-by-step guide. We have remote desktop support enabling people to fix their own devices in their homes with diagrammatic support supplied live to their phones or wearables, showing the exact problem and a walkthrough of how to fix it. We'll see support personnel able to view the issues in situ and see if it warrants a call out or if it can be repaired locally and by somebody else cheaper. I'm personally hanging out for a heads-up display that tells me people's names and where I know them from. And I could use a bit more help with sarcasm detection and something that helps me detect emotions better, truth be told. These are all functions of machine learning, and all of them are in active development, even sarcasm detection. But beyond that, I would love to see augmented reality used with Spotify to recognize your surroundings or activities and tailor your music to match. A machine learning-based soundtrack to your daily activities. I'd love to be able to change my world to be more artistic at the push of a button, or to semantically style transfer people and backgrounds on the fly. I'd love for my works to work in real time rather than being pre-programmed. Or play an AR or VR game and be able to select the style in which it's rendered. To be able to hack my reality and create the visuals and the soundtrack for it as I exist in it, as I move about the world. What purpose does all of this serve? Of course, art doesn't need a purpose, it just is. But the purpose behind the more commercial realizations of this technology are clear. From making the world smaller and more accessible through linguistic assistance and mapping to selling products for that people actually need tailored for them in their homes. Mixed reality can bring the world to you, and machine learning can learn what you need, learn your interests and your tastes, and learn to tailor it for you. But what if it all goes horribly wrong? What if the world ends up cluttered with advertising and targeted attacks on our visuals become the norm? What will we do if we end up in Back to the Future with the holographic billboard from Jaws, or the horrifying advertising world of the art video Hyperreality by Keiichi Matsuda? That's why it is crucial to not let corporations control these technologies, but to disseminate them, to give people a choice, so that it isn't just Facebook, the augmented reality experience, or Google Vision, but a user-curated world of their choosing, filled with art, or filled with information, or products, or the things that matter most to them. We need to see a world where it is what we want to see, where we curate our experiences and our enjoyment. The toolkits I've discussed today are all available to be used by everyone right now to craft amazing experiences and generate wonderment in our worlds. We can be inspired by existing tech or run away with a crazy new idea. But I think that we should use this amazing technology to make the world a better, more beautiful place, and a more welcoming place for everyone. As more companies are working on AR wearables, we can expect to see these technologies cross over more and more. We can see it permeate, and while the focus will be on advertising and selling, I hope that we will also see ways to make our world more beautiful, more filled with the wisdom of the world. And as the power of our phones increase, the more powerful the machine learning interactions will be. Augmented reality is the bridge between the physical and digital worlds. As those worlds get blurred together by the accessibility and pervasiveness of technology, we're going to need that bridge more and more. We will have ways of making the world smaller, whether it's talking to a hologram of a friend in front of you or translating signs and things we need to say on the fly. I hope that it will lead to a world of beautiful flowing graffiti, of artwork waiting to be discovered and interacted with or walked through. A chance to alter our worlds, make them more fantastical, more inspiring, and more beautiful by working together. By connecting that with machine learning, we're allowing machines into our own worlds. Blurring that line even further, we are able to collaborate with machines to teach them and create artwork together that can be seen in the real world through the medium of the screen. Thank you.